This tutorial shows you how to transform records in a database using Talend Open Studio. This technique will give you a huge performance boost when you're taking records from one table and moving them to another table in the same database. I have a table called Customer, and there are two fields, commission rate and commission effective date, that are going to be set when I load these records. And what I've done is I've staged them. So there's a table that mimics the customer table containing data from, say, a text file or some other input source. In this relational model, I have a customer table and a commission table. The stage customer table in green is my input. And what I'm going to do is, in addition to loading the customer table from the stage customer table, I'm going to perform a lookup along the way. And that lookup is going to be done on the commission table. The commission table has an area code. The stage customer table has a phone number. And I'm going to take the phone number, extract the area code, and that's going to be the basis for a join on the commission table. I've also provided for defaults. So if the phone number is not found in the commission table, I'm going to assign it an area code of DEF, and that's going to be used as the lookup value. Before I present the in-database transformation job, I'd like to take a step back and present a job that'll be familiar to the casual Talend user. This is a job that involves T-Oracle input, T-Oracle output, and T-map components. In this job, stage customer will be read from and joined against the commission table using a T-map. And then those records will be written out to the customer table. And this job is going to work fine for a limited number of records. However, it has a huge drawback in that the records need to be pulled out of the database across a network, which is a costly operation, and into a JVM. And then the reverse occurs on output, another costly network operation, such that if I were to run this job over my million record input, I would find that the job takes well over an hour. And I'm going to show you when I do the in-database transformation that it'll take under a minute. But looking over this job is important because I'm going to be expressing some things in the in-database job that are less familiar, and the comparing and contrasting will help you get started with some of the newer components. So in this case, I have T-Oracle inputs on the stage customer commission, and they have a query fed into the T-map. And my join condition, rather than being a straight up join on two column values, it's actually an expression. And one thing to note in this particular job is that it's a Java expression. And you're going to see that it's rendered differently in the in-database transformation. And I have a Java expression that's checking for null, making sure the length's adequate, taking a substring, and if that substring or the value isn't there, there's no phone number, I'm going to give it a value of DEF. And that's going to be the basis for what I join on the commission table. So in this case, we'll look at the stage records. I have a first name, last name, and a phone number. In the commission table, two of its columns are area code and commission rate. And running this won't be any problem. Another expression to note is in my setting of the effective date, I have another Java expression, a new Java util date. So in my T-map, I'm expressing transformations, substring operations, date operations. I'm expressing them using Java. When I get to the T-Oracle output, I'm using an Oracle sequence, and that's rendered in the Advanced Settings tab. And what you can see here is I have a customer ID seek next val. And this is the way in which you'll take a customer table and use a next val for Oracle. SQL Server, other databases that are using auto increment, they have a different technique for using those integer type of identifiers. An in-database transformation can bring you a huge performance boost compared with shuttling records in and out of the database, as is done when you're using components like T-Oracle Input, T-Map, and T-Oracle Output. In fact, sometimes that T-Oracle Input Output, the shuttling of the records, it makes your solution unfeasible. Load times taking, tens of hours. Whereas when we're rendering things within the database, we get the fastest that it's going to be. These components are arranged and look very similar to those that are done in the job using the T-Map, but I'm using a TELT Oracle map, and these components contribute to form a SQL string that'll be issued with the connection set up in my connection components. It's a little bit different because you're not able to use some of the components that you're maybe familiar with back in the job using the T-Map. In this here, I can troubleshoot, for example, using a T-log row, and I can place that T-log row in any of these flows and get some feedback and watch the job as it's coursing through record by record. I don't have that flexibility with the TELT because these aren't actually creating flows as much as they're just going to form a SQL string. So that's a little bit of a downside with this approach. The inputs and outputs are based as the input components and output components from the other job. They're based on the metadata that was loaded up. So I just drag onto the canvas and you'll have an option for an ELT component here. And I've got a similar setup with the stage customer and also the output. So they're all based on the metadata. The TELT map is a little bit different, and one thing that we can contrast right away is the lack of Java in the expressions. As you may recall, I used a Java expression to join the records together. Well, that's not used anymore. Rather, I have to use an Oracle expression. So note the NVL, the substr, in place of the Java strings, substring, the null checks, the tertiary operator. And over here on the target side, I'm not using a new Java util date. So all of the expressions that are found in here are going to be vendor specific. So when I want a next val, I'm going to put in the next val column, just as that was found in my Oracle output connection, Oracle output component, and the sysdate and the phone number working is done with Oracle SQL. And when I run this here, I wouldn't even try to run the previous job because it was going to take over an hour, probably an hour 15. But here what you'll see is Oracle, Talend is going to spit out the Oracle statement that's run. And in about a minute, you're going to find 1 million records have been loaded. And this is a great way, too, to troubleshoot what's going on. So as you're working with these components, you can sometimes take the statement or sections of the statement and kind of meet the job development halfway by trying to look at it from the SQL vantage point. It may help you with your T-Oracle map setup. And you see that it ran 10:19 and it started at 10:18. So under a minute for 1 million records. And that's exactly the kind of speed up that we want. When I go to my table, I have 1 million records in the stage customer table. I have 1 million records in my customer table. And just to get a feel for what these customer records look like, you'll notice the commission rates being set. So this is a type of job where we're trading off a little bit of the maintenance in that we can't use as many of the components and routines that we may be used to in our Talend job, but the performance boost is huge. And it may be the case that this is really the only way for you to get your data loaded. If you were to try to load this data, I've estimated it'll take about 1 hour 15. Now, if you've got more complexity, more transformations involved, this is where you can run into trouble in your load schedule. So if you find yourself dealing with, let's say, more than 1,000 records, you should start to lean on the in-database transformations here. Of course, neither of these jobs address the onboarding of the records coming from, say, a text file or a web service. That still, of course, needs to be done procedurally using those Oracle input or bulk input type components.